Okay. Good afternoon, everyone. This is Sina Adibi. I'm the VASI member responsible for the website and the treasurer. Tonight we have our Wings program. It's going to be hosted by Dave Wimberly, our president, and our guest speaker is Tom Slater. Everybody is in listen-only mode. If you look at the little window to the right, if you don't see it, there's a orange arrow. If you click on that, you'll be able to type in your questions. So we encourage you to type in your questions, and at the very end, hopefully we'll have some time and we'll be able to read those questions off and get them answered for you. We have a fun interactive session queued up today, so hope that you will stay for the duration. Thank you very much, and take it away, Dave.
Okay, good evening, ladies and gentlemen. Welcome to the November meeting of VASI, V-A-S-I. For those of you who don't know, this is Venice Aviation Society Incorporated in Venice, Florida. You remember the VASI lights. I know Tom knows all about VASI lights. Those are to guide you as a pilot to the runway. And that's our acronym to guide the Venice airport. And our mission statement is the long-term viability of the Venice airport as a safe and modern general aviation airport. We've worked very hard on that project since 1991 or 2, and over the past 10 years, over $30 million has been spent on this airport to achieve that safe and modern GA airport. To start off, we're going to ask you a question. You can respond, as Sina told you. How many hours PIC, pilot command time, have you flown in the last calendar year? Now, your answer will help our speaker later on to know who he's talking to tonight. So there's your quick poll question. Answer that question. How many hours have you flown in the last year? Just go back 12 months and we'll get an idea of what you got there.
Okay.
I'm going to answer my stuff. Okay, I'm going to put that.
I'm going to give everybody about 30 seconds.
Okay.
Looks like
I don't get a vote. Okay.
We've
While
got
that's going down, I'll continue while you're voting. The treasurer requested that I mention dues. It's the dues season. We like to get your dues coming in. We are still trying to have our scholarship program for local students. We have 2 students over at Embry-Riddle University studying aeronautical engineering, and we'd like to continue that in this year. So please, you can go to our website. You can pay with a credit card, PayPal. I'll be at the airport tomorrow for the lunch bunch. If you want to bring cash or a check to me, I'll take it. So bring it in. We will continue online meetings for the foreseeable future. City events are basically canceled in the city of Venice, so our airport open house has been canceled for December. I talked to them today. They may open up late spring. If that starts to happen, we might be able to have our airport open house late in the spring. So here's the answer to our poll. Tom can see this too. Between 10 and 50, 38%, more than 50, 36%. So the higher number, we have 74% in the higher numbers. So that gives Tom an idea of who he's speaking to tonight. Even with the COVID virus floating around the area, guys are getting their flying time in. Our speaker tonight, to introduce Tom Slater, his program is Secret Only Pilots Know About Airports. Tom is a professional engineer. He has a master's from the University of Tennessee, Knoxville, in civil engineering. Go Vols. Big Orange up in Tennessee. I have relatives up here. That's all I hear is go Big Orange. Tom does airport engineering and consulting throughout North Carolina, South Carolina, and Virginia. He's an FAA fast safety rep for many years, now operating out of Raleigh-Durham. In the past, he has been the FAA Safety Rep of the Year for his region. And this program he's going to present tonight has been selected as the Program of the Year in their region. He's a past president of EAA Chapter 506 in Raleigh-Durham. Tom is a commercial pilot. He owns and operates a 2008 Cessna 172 SP. Hope I got that right, Tom. And in his spare time, he's a PA announcer at college football games and basketball games. So, ladies and gentlemen, without further ado, our speaker of the evening, Mr. Tom Slater. Take it away, Cena.
All right. Well, thank you. Hopefully everybody can hear me and see our program. I'll admit I'm not a GoToWebinar expert, but luckily Cena is. So we should do just fine tonight. And thanks for joining us. For those of you who signed up for Fast Wings program, which I hope most of you have, you should receive credit tonight for joining us for our presentation. And again, if you have questions, use your chat feature. And at the end of the program, we'll try and answer as many of them as we can. So this particular program is rated G. It's good for all ages and all experience level of pilots. And here's my promise to you today is at the end of our short session tonight, you will know more about airports than 99% of your fellow pilots. So let's get started. And the first thing we want to do is to take a poll. We call it an exam. And let's do that. So first off, let's see if we can get this to advance. I hope that everybody can see this, and we're going to take a poll on this, and you only get just a few seconds to identify this. What is this? And if you will, Sina, you can orchestrate our poll here, and in just a second, we will get the results.
Okay, very good. So take a good look at the photograph, and here comes your multiple choice.
And Sina, I cannot see the results, so if you'll read those off to me.
Yeah, we're gonna give folks at least like 30 seconds, if not
okay,
more.
That's good. And just let me know what the top choice is.
Sure, I will display too. We got about 65% of the audience. Give them 10 more seconds. And here is the third. So we got 80% of the people voted. So I'm gonna kind of close the poll. And let's see, here it is.
Okay, I cannot see your poll, but
I'm sorry, the poll results are 74% said PAPI, 15% said localizer, 6% said RVR, and GLS.
Okay, well, good. I'm glad to see we started off kind of early or kind of easy, and it in fact is a 4-box PAPI. And in the background, you'll see which sometimes confuses people, as a lighted windsock. So everybody knows pretty much as pilots how these work. 2 white, 2 red is your optimum, and 4 red is not your optimum. And so good that we've got this going. We're just going to start moving along here. Our next poll question, what is this? And there's your choices there on the left-hand side of your screen. And hopefully some of you, but these don't occur at all airports, but they occur at some of the larger airports.
Okay, we've got about half of the folks voting. Well, Tom, people are more enthusiastic about this one than the previous one. I think a lot of people know the answer on this. And
well, that would be a good answer then.
Well, it's an easy test. Thank you, Tom. Couple of more seconds, and I think that's about right.
All right, just tell me what your top choice is.
And the results are, top choice is 79% is ILS hold.
ILS hold. Well, you're correct. It is an ILS hold. And again, we don't see these at every airport, but here's the rest of the story. So for ILS hold line, and here's an example of one here, when do you typically use this? And believe it or not, we have a lot of pilots that don't know that these are generally in effect when the ceiling is below 800 feet and or the visibility is below 2 miles, or as air traffic control might direct you. And again, this is for a precision approach, and we have different criteria for that. And we'll talk a little bit later about what those are. Okay, let's go to our next question. Here it is, and I want you to look closely here as we have 3 different aircraft, position 1, position 2, and position 3. And my question to you is, an aircraft that is holding to access runway 4 left, 23 right, which is the proper holding position? 1, 2, or 3? And go with your poll.
Okay, here we have the poll. Okay, I think we don't need the full 30 seconds on this one. We've got everybody
Okay.
voting. And let's see, let's stop the poll. And the results are, wow, 50% said position 3 and 46% said position 2.
All right, so almost evenly split between position 3 and position 2.
That's correct.
Okay, great. Well, this is a towered airport, and if you decided to hold at position 2, you would likely get a call from ATC. Position 3 is correct, and position 2, which is in the middle between these 2 hold lines, is what's called no man's land, and nobody holds in no man's land. This is a rare event that you see this, but this is 2 closely situated parallel runways, again at a relatively major airport. This one happens to be in Honolulu, but this is an event that causes a lot of runway incursions. And so tonight, you know now the proper holding position when you see this occur. All right, next question. And you see the opportunities there on the left-hand side of the screen to identify what this is.
Okay, here comes the poll. And please choose your answers. You got 15 more seconds left. A lot of people are thinking, Tom, it's not as fast.
Okay.
Yeah. I'm one of them, so I'm still scratching my head, and I know the answer too. So, all right, 72% voted and 30 seconds. Let's see. And the, okay, so we've got 33% even split between geographic position and rotor wing pad.
Okay.
And in second place is gate marking. And then distant second is the taxiway crossing and the last option. So
okay, great.
Which is it?
Which is it? It's called a geographic position marking. You don't see these very often, especially at small airports. But here's the rest of the story. These are normally on low visibility taxi routes called SMEGs, which would mean that they would typically be at a towered airport. And they're typically in effect, again, when the runway visual range is less than a quarter mile and or the ceiling is below the air traffic control cab height. In other words, they can't see you taxiing. So they have these geographic position markings. This one happens to be at Atlanta Hartsfield, but and they are shown on various maps that pilots have or information that they have provided, and they will direct you to these positions, and you better know where they are, and you will hold at those positions. So they're not used very often, but when they are, they're very important. All right. This next one, I want everybody to concentrate here for about 15 or 20 seconds and look at this picture. And the reason is I'm going to ask you to pick one of the following from this list that you cannot determine by just looking at this picture. Are you ready? Here we go. Possible FOD, surface roughness, primary or secondary runway, runway length, type of approach available, and runway direction and width. So which one of those can you not tell by just looking at this picture?
Okay, very good. This one is another toughie. We have only 30% voted at 30 seconds.
If you don't vote, you won't get it wrong, but you also won't get it right.
That's right. I guess Dave and I are golden because we don't get to vote. All right, this looks about 80%, and we gave folks some extra time. And let's see, the survey said 36% said it's a possible FOD. 27% in second place was runway length. And so the question is what you cannot determine. Is that right, Tom?
What can you not determine? And here it is.
Right.
Here's what it is. You can't determine the runway length by absolutely looking at this picture, although it does have a little clue, but not, you can't tell the runway length. But all of these other information you can tell by just looking at this picture. And we're going to show you how to do some of that in this evening's program. Lastly, here's another question we've got. And you can see your choices there on the left. We'll give you just a second. If you don't know the answer to this one, well, you also only get a few seconds to make your decision on what you would do.
Here we go with the poll. I think everybody knows the shorthand. Yeah, runway hold, taxiway hold. Got you. Landing, lasso. Okay. All right, 5 more seconds. And we're at about 80%, so we're gonna pause. And there is the answer is Landon lasso at, I'm sorry, take that back. It's runway hold at 47%, followed by lasso at 38%.
All right, well, that's good. This is called a lasso. Land and hold short. This is on runway 1533 at Washington National Airport or Reagan National. And if you violate this, given the clearance that you would receive from the air traffic control, I guarantee you that you will also be getting a call from air traffic control. So if you don't like land and hold short, don't accept it. All right, so that's the end of our poll. Thank you for joining us. Again, our agenda tonight, pavement markings, NAVAID signing, and hopefully we'll get into a little bit of lighting before we have to stop and take questions and answers. So here we go. First, let's talk about what all of those on the agenda mean in terms of safety. And here's an example of this. Happened in August of 2006 at the Lexington Bluegrass Airport. I have a video, which I'm not going to show tonight, but here's what happened on this very early morning at Lexington Bluegrass. And some of you may remember this, but a Delta flight was cleared to take off on runway 22. There was some construction on the airfield at the time, which closed a couple taxiways. And what happened was that the aircraft, first departing flight of the morning, left the terminal area, which you see on the lower part of your screen, and taxied out to and was cleared to enter runway 22 for departure. You can see that is the long blue line. What actually happened, however, was that the crew, while doing their checks, and in fact was pretty casual in terms of some of their communication and cockpit procedure, actually turned to take off on runway 26, the red line. And after missing numerous visual clues, including the signing, the marking, and in fact, once they started their takeoff roll on runway 26, they noticed something very unusual. There were no edge lights, runway edge lights, as they departed. And yet, believe it or not, even after that, they attempted to take off and obviously did not have enough runway distance to accelerate and climb, which resulted in a crash which had some very disappointing and tragic outcomes. And here's the National Transportation Safety Board's determination on this, was the crew members' failure to use all the available clues. This is lighting, marking, signage, all of this, and failure to cross-check to verify that the airplane was on the correct runway. So visual clues and understanding about the airport is absolutely paramount. There are some other comments that were made by the NTSB, on this, but these were the ones that were substantial to the crew itself. Tragic event. So knowing your pavement markings are very important. And we're experts as pilots on pavement markings, or at least I think we are, right? So let's talk about basic runway markings, some of which, again, maybe you might be familiar with as you fly out of your airport, but others maybe not so. This happens to be the former shuttle landing runway at Cape Canaveral. But I use it because it is an excellent example that shows all the runway surface markings, including some which have been obliterated. So let's talk about some of these. Runway designator, pretty easy in this case. Runway centerline markings, almost obliterated here by the rubber deposits. Threshold markings. These markings here tell us a lot, actually, about the runway, as well as aiming point markings. We'll talk more about those. Touchdown zone, that's a series of 6 markings, including the threshold and the aiming point. Edge markings for the runway, delineating the active pavement available. Displace markings, yellow, white arrows or arrowheads. And finally, yellow markings, which delineate stopways. Now, it's important to know all these, and we're going to see some more examples of these here in just a few minutes. But that is the gambit of pavement markings that you would normally see on a runway. They vary by runway end, obviously, depending upon the type of approaches that you might have. So, visually reading the runway markings can tell the pilot the following: the runway width, the type of approaches that you have available to you on that particular runway end, relative length, we're going to show you how to do that, some restrictions that may be imposed on that runway or runway approach, the condition of the pavement, which again is a visual decision that you make, and whether it's the primary arrival or departure runway. So all of these you can visually tell just by looking out the window of your cockpit. So how do we do that? Well, let's start with runway width. Let's see how many people might know exactly how this happens. So here's runway 24. This happens to be at Ocracoke Island, one of the airports at the Outer Banks here in North Carolina. Here's another example of a runway threshold and runway width, and you can see the common denominator here is the threshold markings, and here's yet another example of a runway, and you'll notice that the runway markings, threshold markings, have a series of white bars, and from those white bars is actually the telltale of how wide the runway is. So does everybody know what the formula is on how to designate or read these markings? Well, here it is. Normally I ask folks if they can guess what the widths are before we actually show this, but here's the formula that we actually use to determine the runway width based on threshold markings if they're available. And here it is. The number of threshold bars divided by 2 times 25. And that will give you, and this is important, the minimum width of the runway in feet that's available for takeoff and landing. So if you were to look on the one runway 24, you could quickly see that that's 50 feet. But in reality, it's actually at this airport 60 feet. But remember what I said, the minimum width is at least 50 feet. But there's not more because it doesn't meet the next criteria of 75 feet, which is what you see on the lower right part of the screen. 3 bars, 6 bolt total, divided by 2 times 25, 75 feet. And in fact, that runway is 75 feet wide and available for runway takeoffs and landings. And of course, the one in the upper right, where we have 12, indicates a runway width of 150 feet. So there it is. Secrets revealed. Just by looking at the threshold markings, you can generally tell what the runway width is. But there are a few exceptions. So let's talk about general rules of thumbs when following markings identify runway. And this time we're going to talk about runway approach categories. So let's talk about this. So we have these following, remember from our slide just a minute ago about certain runway markings. These are all a part of approach markings: touchdown zone, the threshold, which we just looked at, and the aiming point. And here's what we generally find as a rule of thumb on knowing what the runway approach category is based on these 3 markings. So let's look at them again: threshold markings, touchdown zone markings, and aiming point markings. So when you have touchdown zone, as you see here, a series of 6 different markings, they indicate that this is a precision instrument approach, typically an ILS approach. And the total length of those markings, spaced 500 feet apart, is 3,000 feet. They can be shorter in the case of airports where the runway length is less than 7,200 feet. They may have truncated markings where they drop the last touchdown zone marking. But generally speaking, you will see them in this configuration. However, if they just have a threshold marking, but not touchdown zone, almost always you will find a non-precision approach for that runway. Could be a VOR, RNAV, several different types of approaches that are more common these days, but you will typically see a non-precision approach prescribed for that runway end. And lastly is the aiming point, that large block that's 1,000 feet from the end of the threshold. When you see one of those, that typically tells you that you would have at least 4,200 feet of runway available for landing or takeoff. So it gives you a little clue about the distance available on runways. So let's put these into practice. And first, look at this airport in Hanapepe, Hawaii, and notice that, well, they don't have many markings. But we can still read something about this, because if you look at the numerals on the runway, you'll notice one thing peculiar about them. We call them truncated. That is, they're smaller, they're narrower, and they're not as long. And these truncated markings tell you that that runway is less than 50 feet wide. And it also tells you that this is a visual runway, because they don't have any threshold markings and no precision markings. So this is a visual runway, both runway 27 and runway 9, except that runway 9 also has another feature, which we talked about. It has a threshold bar, and it has a series of arrowheads. And that tells us that it is a displaced threshold. The arrowheads that you count, and we're going to go into this a little bit more, will help you with the distance that the displacement is. And in case of an arrowhead, that displacement counts 100 feet. If you have an arrow, a white arrow, that counts 200 feet. But here we have a series of 2 arrowheads, and that means that the displacement is about 200 feet. So visual runway, truncated means narrow, and a displacement. Let's go on further and look at this one. Here's another one, runway 1735. Kind of hard to see runway 17 unless you squint a little bit onto your computer screen, but you'll see that it has no threshold markings. It does have, however, if you can see my pointer, it does have a series of aiming point. And then for runway 35, you'll see that in fact it has some threshold markings and displacement as well. So what do we read from the runway approaches just on this? So runway 17 is a visual runway with at least 4,200 feet of usable runway. And on runway 35, it has a non-precision approach with a 200-foot displacement, and the width is 75 feet. So again, just knowing about the markings tells you a lot by just looking right out your cockpit window. Let's move on to Chattanooga, Tennessee. Here's another. And so based on what we've already talked about, you can see that runway 20, we know has precision approach, and it also is at least 4,200 feet as a precision approach, and in fact is 150 feet wide. So again, by looking at the markings, it helps you determine the approaches and in some cases, other information about the runway itself. Well, by the way, we'll encourage you to write down, if you have a pad and paper and pencil, to write down your questions so that you can, as we go through our presentation, you can be sure to ask your question at the end of our presentation. We're now going to talk about runway length. And here's the rules of thumb on runway length. It can be estimated by reading the number and location markings, such as aiming point, touchdown zone markings, centerline markings, displacement echos, and chevrons. And we're going to show you several examples of how to exactly use these markings to determine runway lengths. Lengths for visual runways, as we just showed you a little earlier, are a little more difficult to estimate. But let's talk about some of these and some of the rules we use when determining runway length. Aiming point markings are approximately 1,000 feet from the runway threshold. Remember that? Touchdown zone markings, including the aiming part, are generally spaced 500 feet apart. Full centerline stripe. If we have a centerline stripe, we typically count that as 200 feet. The stripe is not actually 200 feet long, but the stripe and the accompanying space is about 200 feet in length. If we see a long arrow, that is an arrowhead with an arrow tail, we count that as 200 feet, an arrowhead as 100 feet, and a chevron as 100-foot spacing. So let's just put these into as an example here. Here's Manassas Regional Airport, and you can see the runway, the long runway on the top has a precision approach on runway 16 left, and by knowing the markings on 34 right has a non-precision approach. But how about the length? And how do we determine that length? Well, let's go to our rules that we just talked about. So for precision instrument markings, we're talking about 3,000 feet. Again, just looking out your window, we also have the aiming point markings on 34 right is about 1,000 feet. And if we wanted to count the chevrons, and you can just kind of estimate them, but if you wanted to count the chevrons, there'd be about 11 chevrons. Centerline stripes, they would be about 11 of them, which again, for 200 feet would be about 2,200 feet, which means that this runway length is in fact 6,200 feet long. Again, if you know your markings, you can determine what the relative length of that runway is just by looking out your cockpit window. Here's another example. This happens to be in Asheville, North Carolina. And again, here, this one is fairly simple. We have on runway 1634, we have 2 series of precision instrument markings, along with a series of centerline stripes, whether you estimated that to be 8, 9, or 10. The reality of it is that with the 10 mid-segment stripes, this is 8,000 feet in length, this runway. And you could tell that fairly easily by applying the rules that we just showed you a few minutes ago. We're now going to switch gears and talk a little bit about thresholds. And here is one of my favorite airports in Boston Logan, and we're going to do this fairly quickly. So threshold number 1, that position, are you able to take off with clearance from air traffic control? The answer is absolutely yes. But how about position 2? Could you take off from position 2? Remember, position 2 is on a stopway, and whether you were taking off on runway 19 or 4 left, that would be not permissible. How about position 3 here, which is a runway departure that's about 1,400 feet beyond the threshold of runway 4 right. If you were cleared to take off from that location, it would absolutely be legal. How about position 4? And position 4, would you be legal to take off from that position? And the answer, surprisingly, is no, you would not, because you're not actually physically on the runway. That's not to say that somebody might not be power or spooling up their throttle, but in reality, you have to be cleared. You have to, especially if you're doing a lineup and wait, you have to be cleared beyond the threshold marking. But now let's look at runway position 5. And before we do that, one of the neat things about Boston Logan is this little information here, which everybody can read as taxi. And why in the world do you think that they would have taxi on that very obvious taxiway? Well, because they've had at least 6 aircraft land on that piece of pavement. Again, when you have low visibility, if you're not directly on the center line, you could be confused, especially at night, even though there's blue lights versus white lights. But we've had a series of problems with that. And the same thing with taxiing aircraft who taxi onto the runway instead of taxiing onto the taxiway. So you will see that very unusual pavement marking there at Logan. But let's go back to position 5 here for a minute. Is it legal to take off from position 5 or not? So I did a zoom here of this so you can see we've got a series of white arrows, which would typically mean a displaced threshold, but we also have a yellow center line. And what does that mean? Well, that means yellow would be a taxiway marking. So I've got runway markings and taxiway markings. So can you take off from position 5 that was noted a minute ago? And the answer is yes, you can, because it is considered when active, when runway 4 right is active, it is considered a runway position, and you would be cleared to take off from that location. However, if runway 4 right happens to not be active, then that pavement is actually designated as a runway and taxiway. Kind of unusual. All right, here's another one. This is at Martin State in Maryland, just northeast of Baltimore. Here's the hold lines for runway 15, and here's the relocated threshold. So from position A, can you take off if cleared by air traffic control? The answer is no, because that's a runway end entry taxiway, has yellow markings only, and is not to be used for takeoff. But from position B, across the threshold line, you would be eligible and legal to take off. Just something to know about taxiway and runway markings. Then we have markings that are restrictive in nature, and here's an example at Danville, Virginia. And in this particular case, you'll notice that if you could look closely, you can see some yellow pavement or white pavement markings that were removed here, and the threshold was actually relocated to this location right here for runway 13. I noticed that runway 20 also has a displaced threshold, and so the reason is, why would they have relocated this particular runway threshold, and how much has it been displaced? Well, the reason is because you can't see it on your screen, but this area between runway 20 and runway 13 is high ground. And we actually have had several near miss accidents where we've had aircraft taking off on runway or landing on runway 13 while taking off on runway 20. So what can you tell again about these restrictions? Well, runway 20 is a displaced threshold. If you count the arrows and the arrowheads, it'll tell you that you have 4 times 200 or 800 plus 100, 900 foot displacement on runway 20. And you have about the same on runway 13 as well. But this is now a stopway and not usable pavement for landing or taking off. All right. And of course, there's always the issue about pavement condition, as you saw in the earlier poll slide and this one here. When you have markings that are almost not discernible at all, you have to worry about pavement condition and whether you believe it's safe for you to actually take off or land on or use that particular runway pavement. Again, I would just caution you about that, because typically the pavement marking that is not well displayed typically means that the pavement condition is also not in very good shape. All right. We're now going to quickly talk about taxiway and non-movement area markings. These are pole positions, enhanced centerline markings, edge markings, and non-movement areas. So in this particular instance, for instance, we know these well. This is a hold line. Which direction is the runway? Well, it's actually this direction, because a lot of people get confused about this, especially if they're not familiar with a particular airport that they're in, and the fact that they might have intersecting taxiways in advance of a runway crossing. It becomes difficult. This is what they look like, and again, they come in various shapes and lengths. This one here happens to be an angled one. They're located in a taxiway with an extra wide entry. And here's another one that shows runway designations. And by the way, yes, the runway designation is always shown in the direction or displayed in the direction as you approach the runway end. That runway end designation is also in the correct location or orientation to where you're stopping your aircraft. Enhanced taxiway centerline markings were put into place about 10 years ago now to help with runway incursions. These occur within 150 feet of the hold bar for a runway entry, and they're enhanced in that they're, as you saw just a moment ago, they're highlighted, and they are a visual clue to pilots that you're about to enter a hold area for a runway, which would require, obviously, some reporting. And then we have non-movement lines, like this one here at Manassas, Virginia, where we have a series of taxiway edge markings, like you see here, which actually delineate where you're supposed to taxi within the boundary of these apron taxi lanes, and the reporting line, which is the movement line here, which would take you onto the active taxiway. And they come in various different, they're slightly different in the way airports delineate those in your area. Here's another example. This is at Raleigh-Durham, and I'm going to zoom in here just a little bit to show you the non-movement markings here for the roadway. Then we have a movement area marking, which you see here, and then the taxiway center line and edge marking. So this is called an apron edge taxiway. And notice that the roadway is inside the movement area, which means that they don't have to report to air traffic control or talk to anybody when they utilize that roadway. But as soon as they cross that, or an aircraft in a pushback situation, if they needed to cross that line, would have to call air traffic control. So movement lines are kind of important because there's a requirement. And then there's my favorite here. This happens to be at Craig Fields. Many of you probably who live there in Florida have been to Craig Field. I was parked there at one of the FBOs. Jason, this is the parallel taxiway to runway 523. I happened to be parked in the position you see there. I had gotten some fuel and pulled out from the FBO, and I stopped right there and called air traffic control. And again, as I kind of zoom in on this, you might notice that right here, there's a very faint movement area line right in this location, but over where I was, there was actually no line at all. But I pulled up to right where I'm showing you here, and I stopped, and I called air traffic control, and air traffic control said something to the effect like, "Where are you? And did you receive permission to taxi to that location?" At which I told them, no, I did not. And I'm holding short of the taxiway, and I'm ready to taxi for departure. And they told me that I had not been permissioned to move to there, and that I should have called air traffic control from the ramp. So maybe some of you have discovered that as well. But the reality is I was right, because here's the secret here that you now know. But if you see these other markings here, you'll see that these are actually signs. These are guide signs which tell you what you're on and what you're holding short of. And they're always placed at the taxiway safety area. And that is the legal location at which you can taxi it to before you have to report, unless there's a movement line, which there wasn't. But rather than to school the air traffic controller, who happened to be just under my nose on that day, I decided discretion would be the better part of valor. I apologized, and I decided to move on, understanding that next time, maybe I had better contact air traffic control a little sooner. But the reality of it was, I was in the right. All right. We only have just a very few minutes left. So I'm going to talk just a few minutes about NAVAIDs, and then I'm going to stop and we're going to ask for some questions. So 2 types of NAVAIDs, and here's happens to be one of them. Does anybody know what that is? Well, that's actually a visual NAVAID. It's not recognized by FAA, but as everybody knows, birds always face into the wind, and so this, acting like a windsock, could be a visual aid for the wind direction. But actually, we have 2 different kinds of NAVAIDs: an electronic NAVAID, which establishes bearings, headings, distances, azimuths, and vertical guidance using radio or communication instruments. So electronic, radio, and communication instruments. Visual assist the pilot by seeing the runway environments to safely identify and approach. Does that mean that visual NAVAIDs don't use electricity? No, that's not what it means. But they are a visual aid, which means the pilots have to be able to see that particular NAVAID. So electronic NAVAIDs, there's a host of them. I'm quickly going to talk about 2 or 3 of them. Glide slope localizer, which are part of an ILS, a precision instrument approach, our automated weather system, and then our RVR, which again is a part of the instrument landing system. So glide slopes, and here's the takeaway from this that I would like everybody to know. They're located about 1,200 feet beyond the landing threshold, but more importantly, the accuracy of the glide slope is about 7 degrees from the runway center line. So if you're outside of that and you're getting a glide slope reading, just please know that it may not be totally accurate. They're typically situated so that they give visual vertical guidance to a height of about 50 feet above the threshold, which generally is about a 3-degree vertical approach slope. Localizers are located about 1,000 feet beyond or on the other end of the arrival runway, and they provide a straight electronic signal broadcast directly down the center line of the runway, and their minimum accuracy is assured within 10 degrees of the runway center line for a distance of something like 20 to 25 nautical miles. There are offset localizers, but we won't talk about those tonight. But the important thing to note again is you may pick up a localizer signal, but it doesn't necessarily mean that it's accurate unless you're within this cone of accuracy that's provided by the localizer. And then we have offset localizers, which again are not very frequent anymore these days. We have AWAS, which again report all of the information. You're used to using those almost every time you go to the airport. You notice that they generally report the same things in the same order, and that's not by accident, by purpose. And then they also might report things like types of precipitation, hazardous conditions, or freezing levels. The fact that they might report the gasoline price or something else on there is not necessarily FAA approved. And then we have our RVRs, which give us a runway visual range or the visibility at certain points along the runway, typically on each end and also in the middle. And they're required for instrument landing system approaches or precision approaches. Then we have the visual NAVAIDs, and you see a host of them here in approach lighting NAVAIDs, and those are the ones we'll kind of talk about today. Those are the visual NAVAIDs that we would typically see. Here's the approach lighting system for a Mausar, a very typical location. This is what they look like if they're viewed from your cockpit on approach. And then we also have what's called an ALSEF 2. These are high intensity approach lighting systems used with Cat 2 and Cat 3 approaches, which have minimums lower than a half or a quarter mile. And they're considerably brighter and longer in their length. They're excellent NAVAIDs, and they're also usually come with touchdown zone lighting, which you see in the picture here. We talked about PAPIs, and the interesting thing in this picture here, you'll notice the PAPIs are on the right side. Typically, PAPIs are located on the left side, which is enhanced visual for pilots who fly in the left seat. This one happens to be on the right side. Not all that common, but it is. And again, I think every one of our pilots here tonight probably understands how they work. The interesting thing is, and this is important, is the system has a visual range of about 5 miles during the day and up to 20 miles a night, but the obstruction clearance is within 10 degrees of the center line and only 4 statute miles. In other words, you might be able to see the PAPIs, but if you continue on that glide path, you might lose those PAPIs depending upon terrain or trees or something else. They're only good for 4 miles out. Also, you might see something in the pilot, what do we call these now? Well, most everybody's online now, but you'll notice that you might see something that shows the PAPIs are out indefinitely. Whenever you see a message like that, that typically ought to highlight the fact that there's probably some kind of obstruction in the approach lightings. Yes, these PAPIs do go out on occasion, require maintenance, but the reality of it is, if the PAPIs are out indefinitely, there typically is a problem within the approach. All right, I'm going to stop right there, and rather than get into our airport signing, I'm going to stop right there. Our time is close to 8 o'clock. I wanted to honor that time, but I also wanted the opportunity to take questions. So if you have questions about what we've covered, I'll be glad to take them tonight.
Okay, well, thank you very much, Tom. Very interesting. Lots of acronyms. And we have a number of questions here. Robert should get an extra point, wings point. He caught the fact that we had misspelled lasso as L-A-S-H-O. So I can answer that one. You are correct, Robert. Sorry about that. It is land and hold short, not land and short hold.
Cool. There you go. Excellent. And that's not the first time we've had that comment.
Okay. Michael had a question, and it has to do with if you could please quickly go over how you determine runway lengths.
Sure. Let me scoot back real quick to those slides, and again, we'll show you the critical. We'll show you kind of the critical slide here, which tells you this right here. So this is what you want to take away from runway length. Again, these cues are required. This comes out of an advisory circular on marking runways, which again, most people don't, and pilots don't ever get quizzed on. But these are the kind of the guides that we use to determine length, because they give us a visual. We can count these. Aiming point, 1,000 feet from the threshold of the runway. Threshold markings, again, for precision approach, for precision approaches. The threshold markings are spaced 500 feet apart. So every threshold marking, threshold touchdown marking, are spaced 500 feet apart, and every one of those that you can count is 500 feet of runway length. Center line stripes, count for 200. Just count the stripes, don't count the spaces in between, just count the stripes. A long arrow, whether it's yellow or white, counts 200 feet, an arrowhead 100 feet, and a chevron 100 feet. So again, in the example that we showed for runway length, You can see here on 16 left, we have a precision approach, which is 3,000 feet, 1,000, 2,000, 3,000 feet, another 1,000 feet to this aiming point here, and then we're then counting or estimating our center line stripes. And whether you count 8, 9, 10, 11, you're going to be pretty close on what your distance is for your runway length, and that's shown as 6,200 feet there. So hopefully that answers that question. And again, if you have some interest, you can get my email address, which I'll tell you at the end of this presentation, and I can send you some notes about our presentation tonight.
Excellent. The other question, Louise wants to know what are good sources to get a list of special markings on pavements used in the airport? Do you know any good references or sources?
Yes, I do. Pavement markings. So for pavement markings, this one's pretty easy. I wish I could tell you the exact advisory circular, but there are hundreds of them. But if you will Google FAA advisory circular pavement marking, if you just Google that, it will come up. There will be a listing of the advisory circular that's put out by the FAA. That and it's in a booklet form. It's downloadable as a PDF, and that publication will give you all the information that you need, more than you ever dreamed that you would need, on pavement markings. And they have good examples and they have bad examples, but all of that information is in that advisory circular, and that's the best reference that I could give you.
Perfect. Thank you. I can just share a personal thing, is that AOPA and FAST also have a really interesting online course. It's very short, low impact, obviously nothing as comprehensive as your presentation, Tom, but they really do a good job of showing you the airport markings and so on. Robert wants your email address. You said you were going to share that with us later. That's wonderful. And forgive me, when you were talking, question from Michael is, what are the dimensions of the aiming point marker? Did you answer that?
So the aiming part markings are, I believe they are 200 feet in length, but they're located 1,000 feet from the end of the threshold. And typically the aiming point markings, you see those in this picture that I'm showing you here, that are 1,000 feet. And the reason they're called aiming point is because if you follow the PAPI or the glide slope, they're almost always coincidental with where you would actually touch down on the runway if you are following the proper visual or electronic glide path to the runway. Now, that's not universally true, but it's that would be a common way that they would set up those visual or electronic NAVAIDs on guidance, vertical guidance into the runway. That's why they're called aiming points.
Okay. Question from Eugene is, can you use the displaced threshold at the opposite end of the runway to calculate your landing distance?
The opposite end. Typically, yes, but there are sometimes restrictions imposed by the airport on that. And the reason is sometimes the displacement actually doesn't have a taxiway access to it. Sometimes they extend in some places, I'm trying to think, Camarillo, California is a good example where they have a displacement that's about 3,000 feet long. And so there's it just depends on the frequency of the use and the access of that as to whether you can use that for landing calculations. You can definitely use it for takeoff, obviously. and is one of the ways that we gain takeoff length available. But typically, I would say more times than not, you're going to find that the airport will not allow you. They use what's called declared distances, and they'll have takeoff distance available or TOTAs and landing distance available published. And I think if you research those, you'll find more times than not on the departure end of the runway, they will not allow you to count that for takeoff lengths.
Okay.
Hopefully that answers your question.
Okay. Yeah, Eugene, let us know if that does answer your question. For the next question, if you could please bring up the Boston Airport diagram.
Okay, let me think where that is here. Trying to remember. There we go. Yes, here we go.
Okay. So Wayne wants to know, on the Boston Airport markings, position 4, what instructions to take off as runway threshold is much further down?
So in this particular case, runway, the reason I designate that area is that is on a active taxiway. You notice that in the area here, if you can see my arrow, this is a stopway, so that's not even inhabitable pavement, except by rescue vehicles and things of that. That area is not inhabitable. But this is an active taxiway, and you're not cleared for takeoff on an active taxiway. So theoretically, if you were holding short of runway 9, either here or in this area here, when you would be cleared to take off or to land or to line up and wait, you would taxi across the threshold marking and our threshold bar onto the threshold markings. And so the reason I ask that is because you can't take off from an active taxiway. So if they were to say line up and wait on runway 9, if you lined up and wait on position 4, you would not be in the correct and appropriate position.
Wow. So almost need special training to go to Boston for the first time, I'd imagine. Now,
it's
Tom,
an interesting airport.
Pardon?
It's an interesting airport.
Oh yeah. Oh, I can see. Tom, I know offline when we were talking, you said you had a couple of different presentations. The next question might be relevant to that. Paul wants to know, will you have a follow-up on lighting, the new FAA lighting? Do you have anything on that? Do you have any slides in this one that we cut you short on, first of all?
Well, yes, possibly I do. The lighting is this is typically, and as I think I told some of you, this is actually a 2-part presentation. And again, it's very interactive, so we have a lot of fun while we're actually doing a presentation. Obviously, with COVID and we're doing this online, it's the first time we've done this online like this, but we typically have a session and then a short break and then another session where we can go through in more depth, because some of the information that I left out sharing with you tonight would extend our time beyond what we have. But the answer is yes, I do have some. And again, I can share with you some of that information if you'll email me and give me a little bit of time, depending on how many requests I get. But I can email you some notes about our presentation this evening.
Sure, Tom. Just so that you know, we have a newsletter, monthly newsletter we call the VASI Notams. And if you want to send that to me, I will include it in that newsletter, and then everybody, all the VASI members will get it. And
that sounds like an easy thing to do.
Yeah, certainly. But by all means, please, if anyone reaches out to you, feel free to connect with them. Let me quickly have a look. There are some just general purpose questions that I think would be of interest to you too. Question was asked, how many people did we actually show up? We had about 110 people register, and we had about 80 that actually showed up. That is a phenomenal turnout. Usually about 50% of those who register show. So there's a testament to the level of interest here in Venice. And a question just came in from Pete. Pete wants to know, is the FAA considering different markings for the WAS or the GPS apps? The WAS or GPS?
So I'm not sure about what you're asking me in terms of.
Hold on, there is a follow-up. He's talking about runway markings. Peter, I can actually, if you're there, let me get Peter. I can put him on the spot so he
there
can.
You go. There you go.
Go ahead, Peter. You're online. Ask your question.
Hi, Tom. So you showed us that we had specific runway markings for precision approaches that we could determine on a runway, and also in the lack of those, we could consider. We know that the opposite of the runway example he showed us had an approach, but it wasn't a precision approach. It'd be a non-precision approach at one end of the runway. So with the advent of WAS and GPS approaches to places like Venice here, do we know they're going to stay with the non-precision markings on the runway, or is it going to have some kind of different markings when we're using a GPS or WAS receivers for those kind of approaches?
That is an excellent question. And here's the simplest answer I can give you. As part of your instrument approach, you have two things. You have a decision height and you have visibility. And those go obviously hand in hand for you instrument pilot. So a lot of times we might have on an RNAV GPS approach, we might have, you might get horizontal, obviously, and vertical guidance. And you might even get a decision height as low as 200 feet. But what often happens is that the visibility requirements for a precision approach are not met, in which case they would mark it as a non-precision approach, because again, you might have the decision height down as low as 200 or 250 feet, but you wouldn't have the visibility requirements. Again, GPS doesn't do very good with that. And typically, as a result of that, let's say you had a LPV approach with 200 feet and 3/4 of a mile. Well, that doesn't require an approach lighting system that you would have typically for an ILS, if that makes sense to you. So there's some different NAVAIDs associated with the ILS, which you would not get with an RNAV approach, even an LPV approach, which might take you as low as 200 feet. Does that make sense?
Yeah, it does make sense, knowing the difference between decision heights and alert heights, those kinds of things. So I guess we all have to be careful. If you're going to deal with a 200-foot ceiling, you're not going to break out seeing the typical markings you would see at 200 feet on a precision approach.
Well, yeah, you know, and in certain parts of the country, you can have West Coast is a good example where oftentimes they'll have fog in the morning or very low ceilings, but below that ceiling, you might have 10 miles visibility. And,
exactly.
And that would make your approach much easier than if you had a half mile or 3/4 of a mile. So exactly, that's an excellent question, and we get that fairly frequently.
Oh, thank you.
Perfect. Thank you, Peter. So Tom, did you want to put up your email address? Is that on a slide somewhere?
I don't know if I think I took it off of the front slide. Let me look and see if I put it up here.
Well, I have it. If you don't mind sharing it, I can include it.
I will. So here it is. I'll see if I can maybe I can actually put it I can actually put it on the screen here. Let's see here real quick. If we can do this real quick. Oops, that wasn't too good. All right, now hopefully you can see that.
Perfect.
And that is my email address that you can send to me, and I'll be glad to send you notes on tonight's presentation. You've been a great silent audience, but a great audience none the same. I always enjoy giving these presentations. We rather do them in person, as I'm sure you'd rather be in person, but none the same. I hope that you were able to take away a few pearls of wisdom tonight on things that we mentioned. And again, you know more tonight walking or turning off your computer than most all of the other pilots. Again, you probably weren't quizzed on too much of this on your pilot training or your pilot exam.
Perfect. Tom, I had, as you were wrapping up there, I got at least about 6 enthusiastic comments from the audience thanking you for a very informative session. So I want to thank you. And Dave, did you want to
Yes,
give
I
some
wanted to
closing
step in and
comment?
thank Tom. Thank Tom again, just a great presentation. I learned a lot. I know all the guys learned a lot. And we will be sending you an appreciative gift for helping us out tonight. Cena's our man will take care of that, right, Cena? A little gift for Tom?
Absolutely. You
That's
will
okay.
get some VASI paraphernalia that you should wear proudly up in North Carolina.
I'm sure that I will, and I'm glad to say I won't have to report it to the IRS.
Right, yes. Thanks again, Tom. That was great. Great presentation. And you
Right.
built a big crowd for us, Andy. You drew a big crowd. Thank you very much. Thank you.
All right. Well, thank you, everybody. Have a blessed week and fly safe.
Thank
Fly
you very
safe
much.
and stay safe. Stay safe. That's the key. Thank you
All
very
right,
much.
folks.
Thank you.
Thank you very much, everyone. All right, bye-bye.
Okay, Cena, I want to sign off.
Yes, sir.